This is a solid stir extrusion for metals designed by students at UNT for NASA as part of the 2023 Moon Metal Challenge. UNT students designed a machine where heat is generated via friction to melt the material. The design uses a combination of a retractable rotating tool and a feedstock input to extrude the material at the bottom of the die. However, the material extruded was not continuous and the operation of the design was not the best. Our solution is to implement a hydraulic system for actuator where a continuous feed and a constant force is guaranteed.
So this is our solution, the hydraulic press for actuators and solid stir extrusion, otherwise known as HPAS. Here we have the hydraulic power unit, the muscle of the operation. Here we have the Arduino, the control board, and the 12-volt DC power supply, which is the brains of the operation. Here we have the solenoids and the manifold, which direct the flow of fluid to our cylinders. And here are our cylinders, which will feed from multiple directions, 2 directions to obtain continuous feed. And what you see here on the table are the push rods, which will feed into the channel. And this is the hydraulic press for actuators in solid stir extrusion.
Based on the level of our project, mostly all of the components in our system were parts that we were able to just buy. However, for our system to be complete and for our project to be compatible in the desired application, we did have to come up with a solution for creating push rods to push feedstock into the spindle. Since this part needed to be very specific, and since there was nothing out there that we could just purchase for this purpose, we had to design and machine a custom pushrod solution that screws directly onto the hydraulic actuators. This pushrod consists of 2 parts, a coupler and a rod. Both these parts screw in together, and from there, they screw directly onto the hydraulic actuators. This part, we were easily able to fabricate ourselves to make a custom pushrod perfect for our system.
The electronics of our hydraulic system are controlled via Arduino that executes a code that we have developed. Each of the 2 control valves contains 2 solenoids, one for extending the cylinder and the other for retracting, that are set up as digital outputs, while 2 proximity switches, one for each cylinder, are set up as digital inputs. The code we have developed allows for manual and automatic control of our system. In manual mode, push buttons may be pressed to extend and retract the hydraulic cylinders. In automatic mode, the operation utilizes simple logic to determine extension or retraction of each cylinder to achieve continuous feed. The use of proximity switches ensures that the cylinders do not extend past the length of the feedstock it is required to push. We have also included LEDs as visual feedback to show the state of each cylinder, whether it's extending or retracting.
In conclusion, our team created a more than capable hydraulic system that's ready to take solid stir extrusion to the next level. With continuous feeding creating improved extrudate, our system is ready to take on the challenge of solid stir extrusion. Thank you.